Dear students, uh, in this session, we will have a look on input buffering schemes in a lexical analyzer. So, actually, what is input buffering? We need to store some data in the buffer, input data in the buffer. Instead of reading the entire program, input program from the memory, one character at a time. So, what is the main advantage is that the input might be very slow in the previous, but when we use a buffer, it will be very fast. And definitely for doing this, we need to have a look ahead symbol, what when a match is found or not to decide upon. So lexical analyzer or a scanner uses lexical analyzer or a scanner uses an input buffer which you have it as a buffer pair. So here this is an example for a buffer pair where we are having a input statement x equal to x plus y plus 1. So we have a lexeme beginning pointer and a forward pointer. This forward pointer will account of most of the time. That is, when you have this forward pointer, when you have this forward pointer, it will be just forwarding one lexeme at a time. So when we have the previous session, we will be having two pointers, and for every look ahead we need to have two type of tests to be to be done for each and every scan of a lexeme. But here, when we use a sentinel, which is called as a special character, where here sentinel can be an EOF or can be a hash or can be something which is very, very special and which is not included in the source program as a special symbol. So why, what is the use of this sentinels are? They are special characters, but now when we use a sentinel in each buffer, so at the end of every buffer, so this is the first buffer, so here we are having first half of the buffer, or we can consider this as two buffers. So as of now, we will consider this as first half of the buffer. So this first half of the buffer, we have a sentinel called as EOF, where this EOF is the sentinel character, and for the second half of the buffer we have a separate sentinel called as an EOF. So when this EOF is encountered, this lexeme beginning pointer is starting, and the forward pointer will be just look ahead of one by one character, each and every character at every move, and for one move of the character we have a forward pointer moving towards this end. But when you have a space, it is going to check whether there is a sentinel encountered or not, which marks the end marker. So if it is not there, it is going to again move forward to the next check. That means here, for the instead of doing two tests every time, we will be testing only one called as forward pointer. So it will be just moving forward at each and every scan, and when it reaches a sentinel, it is going to check and whether it is there is a match in the lexeme or not. When there is a match, then the lexeme beginning pointer will move to the next stage. So here only one pointer needs to be tested. That is called as your forward pointer. Okay, but for this forward pointer to be checking with the sentinels, as which we have now assumed as EOF, that is end of file character. So but we need to have a special processing, so we need to decide upon a special character on this. So that is the main crucial step in this, using the sentinels with a buffer pair. Instead of using this single buffer, double buffering scheme is also recommended. and we will just have a very small introduction about the tokens. So why we use a token here? When we use a token called as a very important thing in a lexical analyzer, we need to know these terminologies. That is your what is an alphabet, what is a string, what is a language. So of course we have already gone through this in our TOC course. Alphabet is a finite set of symbols and string is a finite sequence of alphabet symbols and language is a set of strings. And always we can perform this operation: union, concatenation and clean closure operation. So what is a regular expression? It is nothing but a pattern which can be considered as a set of strings and which can derived upon some input alphabet. So here epsilon is a regular expression, A is an alphabet which belongs to the input alphabets, so which denotes the language. When Rn is a regular expressions, this indicates R L of R union L of S, this indicates R dot S, this indicates R star. As we have previously seen, that is union, concatenation and clean closure operation. So there are some extensions. This indicates positive closure. We call it as one or more repetitions, and this indicates a range of characters when we use a square brackets. And this conditional thing which is in a C language, this indicates an optional expression. So we can also give names to the regular expressions like this. So letter is a name indicated for the range of characters small a to z and capital A to z, and digit is the name given to the numbers 0 to 9. An identifier is a name given to letter or digit whole star. This indicates first letter to be appeared, then anything which is following that can appear as an identifier. Usually this is a very famous notation used for variable definition in almost all the languages. And this is a constant where a numeric constant can be represented, and this all these notations are used for finite automata to recognize this regular expression. Here, what is the relationship between regular expressions and finite automata? Here, that means automata is a more machine-like thing, where regular expressions are just syntactical representations. Whereas when we use automata, it is going to use the regular expressions for recognizing any kind of pattern. So for representing that pattern, this regular expression is required. For recognizing that pattern, finite automata is required. So there are many things which we can be used. Unix environments heavily use regular expressions, and also Perl scripting and lexical analyzer, which is a tool, automated tool for creating a lexical analyzer, lex or flex, which is using your regular expressions heavily. So this is the relationship between regular expression, finite automata and regular languages. So expressions are nothing but syntactic representations, whereas regular languages include all the strings which can be derived by those expressions, and this finite automata can define any kind of language and can recognize any kind of language from the from these pool of formal language classes or regular languages. So being seen the difference, some of the operators which we have already discussed, but we will just see what it is. Union of two languages. So here the first operator is union. Union of two languages is nothing but either a language, an alphabet from L or an alphabet from M can appear in a string. When both appears also, it is not a problem. This is called as union. And here L dot M is concatenation of two languages. So here the dot operator usually we will not mention in any expressions, but it is implicitly available. But here duplicates are not allowed in a concatenation operator. And the next operator is a clean closure operator, which is uh, we give it a star. That is, when we use a 0, it is empty string. When we use a 1, it is one occurrence of the string. The power denotes how many times we are concatenating that string. So here L of I represents how many strings to concatenate from the parent language. So union of L of I, arbitrary number of concatenations. So in example, if the language contains L comma 00, then L of 0 is epsilon, L of 1 is once we are doing it, and L of 2 either we can concatenate this 2 times or this 2 times, both one time. 1 1 or 1 0 0 0 0 and 1, or this 2 times. So maximum 2 number of concatenations are allowed. That is 2 times the strings can be concatenated. This is L of 3. Like this we can continue till L of infinity. In the next session, we will discuss more on the operations and also on the finite automata machines. Thank you.